Hello students, in this video I am explaining basic grayscale morphological operations. Let us see what is the basic points regarding the morphology. Once segmentation is complete, we know the different types of segmentations. Once segmentation is complete, morphological operations can be used to improve imperfections in the segmented image and provide information on the form and structure of the image. Okay, means the morphological operations are used to remove the imperfections that obtained after the segmentation of the image. What is morphology? Morphological image processing or morphology describes a range of image processing techniques that deal with the shape or morphology of features in an image. Okay, so the morphology deals with the shape of the images or the features of images. Okay, as I said, morphological operations are typically applied to remove imperfections introduced during segmentation. So these will typically operate on bilevel images because after the segmentation we know the result is only two things, black and white, you'll get binary image. So the morphology is on the bilevel images. This is an example for morphological processing. The first image is the image after segmentation. This is the biometric image. And the second image after segmentation and morphological processing. See, there are many imperfections, small dots which are undesirable. With the concept of morphological processing, you can remove all these imperfections. See here, you're seeing a good image. Then this morphology uses two types of sets. The first one is the set of objects. Objects means sets of foreground pixels. And structuring element SEs, small sets used to probe or modify objects. Okay, suppose if you see this example, all these, what is the image here? This is the biometric image. What is the foreground? All these curves and circles which are in white intensity are called the foreground. The background is black. So here the object means consisting of foreground pixels and structuring elements is used to modify the object. What is the structuring element? This is very important in morphology. The structuring element is a small predefined shape used to probe or modify objects in a binary or grayscale image during morphological operations like erosion, dilation, opening and closing. Okay. The structuring element is made up of three possible pixel types. Foreground pixels means those are represented with the 1 value and the background 0 and the don't care. Means in the case of don't care, that is the cross symbol, you can take the don't care depending on your requirement. You can take it as 1 means the foreground or the background. Okay. Structuring elements can be any size and make any shape. These may be like rectangular, square or disc. But here for the simplicity we are using rectangular structuring elements with their origin at the middle pixel. See, these are all the examples of structuring elements. This center pixel is the origin for the structuring element. If you see the structuring element, yes, if you recollect the past concepts of image processing, you have the concept of mask or window in the case of spatial filtering. Those masks or window or kernel are similar to these structuring elements. And you know the operation of spatial filtering. In the spatial filtering concept, you have to apply the mask on the image. Means you have to coincide, you have to overlap the pixel of the image and the center of the mask. Okay, and then you take the products of the corresponding pixel intensities and the mask coefficients, and you have to sum all those coefficients, all those products, and the result value you have to keep in the output pixel location, the same corresponding location of the input image pixel. Okay, so that is the process of spatial filtering. We know it very well. Here also the structuring element is similar to the windows or similar to the mask. Now, how to do this fundamental operation of morphology? Fundamentally, morphological image processing is very like spatial filtering. The structuring element is moved across every pixel in the original image to give a pixel in a new processed image. Okay, here also you have to move the structuring element across the image to give a new processed image. But here there is no concept of multiplying the pixel intensity, means the original image, input image pixel intensity and the weight of the structuring element. There is no that type of concept. The concept is very simple. The value of this new pixel depends on the operation performed. And as I mentioned here, we have four types of morphological operations: erosion, dilation, opening and closing. Okay, so these are the basic gray level morphological operations. Okay, see here, I'll explain the concept of morphology and the structuring element object by taking one example. See, this is the example. This is the original image I. This is the structuring element. The structuring element is a rectangular structuring element whose center is this. This is the center of the structuring element. Here, perform the following morphological operations. What are the operations? Form a new image. This is the new image of the same size I, okay, like the original image, consisting only of background values initially. Okay, so initially you have to consider an output image which consists of only background values. What are the background values here? The background values are the small square boxes white. Okay, initially this output image is not consisting of this blue boxes, it consists of all the white boxes. Now translate means slide B over image I. This is the B. You have to translate this B over the image I. And at each increment of translation, if B is completely contained in A, mark the location of the origin of B as a foreground pixel in the new image. Otherwise, leave it as a background point. I'll explain. Take this structuring element first. Then you have to overlap the center of the structuring element with the first pixel of the image. You see, I am drawing the image. I am drawing the structuring element. This is a structuring element. Okay, this is a center. Now if you observe, what is the overlapping here? Only this portion means the B is not completely in A. A means the foreground of the image I, remember. So yes, what you have to do? You have to replace this center pixel, means the first pixel position of the image, first pixel position of the output image with the background. What is the background? White. So that is the reason it is white. Now if you move like this, if you move the structuring element like this, then all the time the structuring element is not in A. Otherwise, not in A. Yes, let us take like this next position. If you move like this, yes, then only these two are in A. Okay, yes, the structuring element is not completely in A. So that is the reason the center location is again with the background, means with the white intensity. So like that, if you move the structuring element for this entire row, there is no perfect condition of B in A. That is the reason this first row of the output is completely, yes, we left all those in pixels as background points with white intensity. Okay, then move to the second one, second row. Okay, just move to the second row like this. This is a center, you have to keep this as a center. Then take your structuring element like this. Okay, then even if you see only these two structuring elements pixels are in A, okay, the rest are not in A. So again, that is the reason this location of the output image is with white. Then move to this position. Now if you move to this position, yes, again here also only 4 are in A, other are not in A. So that is the reason this center one is again with white. Fine. So now if you move like this, yes, for this entire second row, if you move the structuring element, okay, or if you do the translation of the structuring element along that row, every time only certain pixels of the structuring element are in A, some are not in A. So that is the reason this entire row is with white only, means as background. We left it as background. Okay. Now I'll move to the third row. Means this is the first point. This is the structuring element. So what is happening again? So if you see, only these three are in A, this 6 are not in A, so that is the reason it is with white. Now if you move or translate your structuring element to the next one, yes, this is the center. So again 6 are in A, 3 are not in A, so that is the reason it gets white. Okay, if suppose now if you move the structuring element, or if you translate the structuring element, see this is the structuring element. Yes, now this is the center. If you see, yes, the structuring element is completely in A. Okay, so that is the reason this third row, third pixel, third column pixel is with the foreground. See the foreground. Again, if you move the structuring element like this, again for this center also the structuring element is completely in A. That is the reason it is with foreground value, that is blue. So in that way, if you move the structuring elements for all the rows, and if you consider only the B completely in A, okay, then only you have to replace that position of the output image with the foreground value, otherwise leave it as background. Okay, so now if you observe the output image, what is happening? Just observe okay, compare the input image and the output image. What is happening? Yes, the size of the input image gets decreased. Okay, so this is the concept of erosion. Okay, so this is the example for morphology. I think you understand it very clearly now. Yes, there are two basic morphological operations, erosion and dilation. What is erosion? Erosion of A by B denoted A eroded by B is defined as A eroded by B is, this is the equation for erosion. Here A is as usual our image, B is the structuring element, okay, and Z are foreground values. This equation indicates that the erosion of A by B is a set of all points Z such that B translated by Z is contained in A. What is a Z here? All these foreground pixels, okay. Now when you are translating B in that foreground, if whenever B is in A, B is completely in A, then you have to make that output image pixel value as the foreground. So this equation indicates that the erosion of A by B is a set of all points Z such that B translated by Z is contained in A. Means the output consists of all the foreground pixels for which the structuring element B is completely in A. Okay, so that is erosion. See the example. So if this is the structuring element, like this explanation, by following this explanation, if you apply the structuring element starting from this, is only this portion is, this is the portion, structuring element portion, means the pattern is this plus pattern, means all these 5 blue values must be in A. Okay, what is A here? This whole image, only this blue part is A. So now if you observe, yes, there is no overlapping, means the B is not in A. So this is the background. If you move like this, yes, the first row is completely the background, and up to this is completely the background. Now if you go for this point, suppose this point, yes, what is happening is, suppose take this structuring element like this. Okay, yes, here is the blue, here is the blue, here is the blue, here is the blue. Only 3 blue portions are in A. The rest 2 are not in A. That is the reason this position of the output image is also not with the A. It is with the background. Okay, to take the difference, to give the difference here, just I used only the green. Okay, yes, for all this, if the structuring element is moved like this, for all the second row, yes, you won't get any complete overlapping of the structuring element with the A. Okay, so that is the reason, yes, this green is nothing but your background, remember. Okay, suppose if your, yes, when will be, there is exact coincidence, you tell me for the third row, there exists exact coincidence only when your structuring element is like this, okay. Yes, this portion, this and this, all the 5 values of the structuring element are in A. So that is the reason, yes, only this corresponding pixel of the output image is with blue. Okay. Even for the next position also it is completely in A, that is the reason it is with. So in that way you can get this processed image. So if you see the erosion is decreasing the size of the original image. So this is the example for erosion. Original image, erosion by 3 by 3 square structuring element, erosion by 5 by 5 square structuring element. This is another example, original image. After erosion with a disc type structuring element of radius 5. See, yes, all these lines are disappeared. We removed all these lines. After erosion with a disc of radius 10, yes, even this line is also eroded, removed. And after erosion with a disc of radius 20, even these lines are also removed. This is the erosion concept. So what is erosion for? Erosion can split apart joined objects. Because erosion is shrinking the object. Suppose if you see this first one, then if the size of these two, circle and square, are decreased, then what will happen? There exists separation. So erosion can split apart joint objects. Erosion can strip away extrusions. Okay. When you decrease the size of the image, automatically it can strip away extrusions. So what is the watch out here? Erosion shrinks objects. Okay. The same way, this is the dilation case. The dilation of A by B denoted by A dilated by B is defined as this. This is the equation. So what is this equation? When your this B cap is nothing but reflection. Okay, B cap is nothing but reflection. This equation is based on reflecting B about its origin and translating the reflection by Z as an erosion. First you have to take the structuring element, then reflect it. Okay, means you have to you know the reflection concept. After the reflection, yes, you follow just like erosion concept. You translate the reflected B onto the over the image and do the same process of erosion. The dilation of A by B then is a set of all displacement Z such that the foreground elements of B cap overlap at least one element of A. Okay, you have to remember that concept. The process is same as the erosion, but not with the structuring element B, it is with the reflected structuring element. That is the first point. And the second point is, when you are moving across the image, yes, in the erosion concept what we did, complete B must be in A, but in the dilation concept, at least one coincidence is enough. One coincidence is enough. That is the concept of dilation. See here, suppose if you take the structuring element in the same structuring element, for the first row, take this, where is the at least single point. Suppose if this is the first position, yes, there is no at least single coincidence or single structuring element in A. Okay, at least single. So yes, the center point is with the background. Then if you move to the second one, here also there is no coincidence. So the third is also with the background. Okay, then this point, suppose this point, yes, here also this one and this one, these are blues. So not with within A. So again, so the third one is with the background. Okay, but if the structuring element is here, suppose if you take this as the origin, if the structuring element is here, yes, what are the blue parts? What are the blue parts? This one, this one, this one and this one. Okay, means one structuring element is overlapped with A. Means the foreground, that is Z. Okay, so what do you have to do? You have to make this position of the output image also with the foreground. Okay, means this is also blue. But to get the difference here, I just colored with green. But the output image is total. This total is the output image. Okay, at least one overlapping is enough. Even if you move this. Okay, here also this. So again there exists one overlapping. So that is the reason this is also with the foreground. Even when you move the structuring element like this, here also there exists coincidence with one point, overlapping with one point. So that is the reason this is like this. Okay, so in that way, if you go for the second or third row, you'll get this as the output image. So if you observe, yes, what is the output image? Output image is with the dilation. Dilated pixels means the size of the image gets increased. You have to consider the image along with this green part. Okay, so that is the dilation. I will show you the erosion. The same erosion. See, erosion is, yes, it gets decreased. The original image gets decreased, means the eroded. Okay, you have to consider only the blue part. You must not consider the green part because it is for the difference only I have shown here. Okay, this is the dilation example 2. So the original image, dilation by 3 by 3 structuring element, dilation by 5 by 5 structuring element. So it is increasing the size of the image. See, this is also used to connect the broken text. If you see this EA, it is the broken text, but with the application of dilation, yes, you can connect that broken text because it is increasing the size of the image. So what is dilation for? Dilation can repair breaks. See this, as dilation is increasing the size of the image, it repairs the breaks. Dilation can repair intrusions. Erosion can remove extrusions. Here it repair intrusions. See, it adds this, means it fills this small gaps. So what is the important point here? Dilation enlarges objects. Okay. So this is about erosion and dilation. There exist some compound operations. Erosion and dilation combinedly can do two operations called opening and closing. See, what is opening? Opening is erosion plus dilation. Erosion must be followed by dilation, then that is called opening. It is used to remove small things from the object. What it does? It smooths the shape, removes thin lines, removes small irregularities and breaks thin connections. And closing is dilation followed by erosion. It fills small gaps in the object. It smooths the shape, joins small breaks, fills holes and closes small gaps. Okay. Now see the opening. The opening of set A by structuring element B. What is A here? Image. What is B here? Structuring element. Is denoted by A opened by B is defined as, so this is the equation. What is this? This is first the erosion and this plus symbol is for dilation. First you have to erode the image A with the structuring element B and the result must be dilated by B. Okay, so that is opening. Erosion followed by dilation. Yes, that the opening A by B is the erosion of A by B followed by the dilation of the result by B. See the example, this is the original shape and this is after erosion. We know the erosion shrinks the objects, that is the reason this connection between this part and this part is disappeared here. But after the disappeared here and after the dilation, see this, yes, the size of the objects gets increased. Okay, so this is the opening. Here for this example, disc shaped structuring element is used. So this is the opening example. First erosion followed by dilation. Suppose for this structuring element, okay, roughly if you see, yes, where is the erosion output? Yes, this fits only at this part, and at this part. Am I correct? This fits only these two parts. Erosion means B must be completely in A. It happens only in these portions. So what is the output of erosion? Only this pixel and this pixel. These two parts, only these two parts. But if you dilate this result with the same structuring element, what you know about dilation? One pixel overlapping is enough. Am I correct? So this is the opening example. Now this is the closing. Closing means first dilation followed by erosion. This is the example. This is the original shape. Yes, after dilation you will get enlarging of the original shape. Then this is the after erosion. So this is the example. You know, yes, first is dilation. So the shape gets increased, then followed by erosion. This is the output. If you want, you can move the structuring element for all the rows and you will definitely get that processed image. This is the example for closing. Okay. So these are the basic morphological operations. So in this video, I covered totally erosion, dilation and the compound operations, opening and closing. Okay. Thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.